So in this video, we're going to show you how to answer this question: which radioactive isotope was in the painting? And so the first thing that we are going to do, or we have already done, is with this problem is identify our given and information are find. And then we use that to figure out which equation we're going to use first, which one we're going to use second. So we look at our find. Our find tells us not the equation we'll use first, but the one we'll use second. So since I'm asked to find the half-life, the equation that I'm going to use second or last will be equation A. That means the first equation I'm going to use is equation B. And whatever equation you use first is the one you're going to use to find your number of half-life cycles. So the thing is, whenever you're using equation B, you just keep in the back of your mind, you will be using some sort of log to solve. Whether you're doing mental math or you're using the log operation, because you're going to solve for this exponent. All right, let's go ahead and get into the problem. So we're going to plug in our final amount here. So our final amount is 23.2 micrograms. We're going to plug our initial amount up here, 130 micrograms. And then our unknown will be the HLC. Okay, so we're going to isolate our unknown using inverse operations, of course. If you have a fraction next to an equal sign, the shortcut is to use cross multiplication. If you're curious about what's not the shortcut, it's multiplying by common denominator there, or getting them to be common denominators. So you multiply whatever denominator is in the first fraction with the one that's in the second. But cross multiplication works just as well, and we've done that. So when we do our cross multiplication, we'll take the 23.2 and multiply it by the 2 raised to the power of HLC. And then on the other side, we have 1 times 130. Okay, and of course it doesn't matter if you put the 130 here and then this expression, the 23.2 times 2 to the power of HLC on the right side of the equal sign, it's equivalent, so it doesn't matter which order you do it in technically. Okay, so now what we're going to do is we're going to further isolate our unknown. So you may be thinking, oh, I can go ahead and distribute that 23.2 with the 2. Nope, these are not like terms. So in order to isolate it, what I'm going to do is divide both sides by 23.2 to get that unknown further by itself. That takes care of that on that side. Now I have 2 raised to the power of HLC is equal to 130 divided by 23.2. So let's figure out what the 130 divided by 23.2 is. That's 5.60, right? So what I have here is 2 raised to the power of HLC, which is our number of half-life cycles, is equal to 5.60. Okay, so now what I want to do is I want to solve for a power. Whenever you want to solve for a power, you need to use log. So the log expression here, so my HLC, all right, my number of HLCs, is equal to log base 2 of 5.60. Now, if you have a fancy calculator where you can change the base of your log, then great. But my calculator, notice it just says log. There's no letter here so I can change the variable. If you just have log like this, the base is 10. So that little number will be a 10 on this for this function. So in that case, what I'm going to do with my not so fancy but still cool calculator is I'm going to use a property of logs to solve. So with this property, you take the log of what's called the argument, the 5.60. So the big number, you can call it the big number, log of the big number, and divide it by log of the smaller number. And these two logs here are log base 10. So I just plug that into my calculator. So I'm going to do the 5.6 is already saved as my answer, so I'll do log of my answer, second answer. So that's a 5.6 divided by log of 2, log base 10 of 2. And then I get this value here, 2.49, let's say. So my HLC is equal to 2.49. That means there's been 2.49 half-life during this 75 years. Okay, now we can finish this up. So now what we're going to do is we're going to use this equation. All right. So we're going to do our half-life cycle. I'll just put this equation on top just to make it easier to see. So our half-life cycle, 2.49, is equal to our elapsed time, which we have is 75 years. So we plugged 75 years in for our ET, 75. And I'm looking for the half-lives. And I'm going to use this half-life to figure out which radioactive isotope we have. So whatever half-life I get, I'll match it to the radioactive isotope that fits that. Okay, so we have 2.49. And I want to isolate my unknown here, my half-lives. Whenever I have a fraction next to an equal sign, I use cross multiplication. It's kind of counterintuitive, because if you have a fraction next to a multiplication sign, you multiply straight across, right? But if you have a fraction next to an equal sign, you do cross multiplication. It kind of looks like you're making an X or a multiplication symbol. So sometimes people get those confused. Anyway, all right. So I have 2.49 times L, or a half-life. So, oops. HL is equal to 75. Cool. Now what I'm going to do to solve for my half-life is I'm going to divide both sides by 2.49. Take care of that. 75 divided by, I'll just do second answer because it was saved in my calculator. So that gives me about 30.2. My half-lives, number of half-lives is equal to 30.2. Check my sig figs. There's 75 years here, so I'm going to reduce that. For sig figs purposes, I'm going to reduce that down to 30 with a period at the end, so that I know that there are 2 sig figs. Again, you can ignore the sig figs part for right now, because we haven't really spent that much time on them. You just had like a little bit of practice, but I just want to start showing you what that looks like. Now, in terms of the half-life, don't forget the units. We're going to use the units of years, because half-life is the amount of time, right? So we need to use units for time, and it has to match whatever information we were given. All right, so if you put 30.2, that's fine. If you put 30, that's fine too. And then that is it. So that's how we do that problem. All right, I hope you found this video helpful. Have a positive day.